for his remarkable commitment to the field of material science. Michio Kaku has recently declared that the James Webb Space Telescope has observed 6 tremendous systems that experts thought couldn't exist. These revelations have the potential to open new perspectives in our understanding of the universe. The discovery is both exciting and challenging, questioning existing theories about the formation and evolution of galaxies. It is therefore worth keeping an eye on these developments. The affirmation by such a recognized expert highlights the significance of these discoveries. Michio Kaku is a remarkable figure in the scientific field, a physicist of American and Japanese heritage. He is regarded as an expert in both classical experimental physics and quantum mechanics. Unlike some more conservative and skeptical experts, Kaku has been receptive to the groundbreaking results of the James Webb Space Telescope mission. His willingness to embrace new discoveries and share them with the public demonstrates his commitment to advancing our understanding of the universe. We are pleased that this esteemed scientist has chosen to break his silence and openly share what can no longer be denied. The enthusiasm and focused tone of the renowned physicist are evident in his comments on the discoveries made by the James Webb Space Telescope, indicating that this development has sparked his interest. Join us as we explore the implications of Michio Kaku's revelation of these 6 gigantic systems. Kaku is a scientist who has always been open to exploring new theories. Throughout his career, he has shown a willingness to entertain ideas that challenge the status quo, understanding that Einstein's theories of relativity and Newton's laws, while fundamental, are insufficient to explain the full complexity of the universe. Kaku appreciates that the discoveries of the new telescope have the potential to advance the field of cosmology, although many of his colleagues have yet to adopt this view. This has caused concern and restlessness among Big Bang proponents and critics of quantum mechanics. However, Kaku merely finds amusement in this. The JWST has revealed the existence of 6 giant galaxies dating back to the earliest epochs of the universe. Each of these impressive galaxies contains more stars than our own Milky Way, despite having formed only a short time after the Big Bang. The team of space scientists who made the discovery has named these extraordinary galaxies universe breakers, because if confirmed they would profoundly alter our understanding of the universe. The consequences of these discoveries are significant, suggesting that the universe's early years were much more dynamic and complex than previously thought, something no longer fits within the current model. The theory of cosmic formation tells us that the universe was chaotic following the initial event, and that the first solid objects required an immense amount of time to form. It took even longer for these objects to reach sufficient density and emit light. The formation of complex structures like galaxies was believed to occur much later. Some of the newly discovered galaxies outshine the Milky Way, and their immense brightness suggests that they were likely forming many new stars every year. While our galaxy forms stars intermittently, it remains unclear when the first galaxies truly emerged. Researchers have yet to determine this. The only clear point is that initially there could have been only single stars or small star groups that eventually combined to form larger structures. Over time, dwarf galaxies fostered small cosmic structures that grew larger and larger. Incredibly large galaxies were believed incapable of existing at that time, which raises the question of whether the universe is much older than recently assumed, or if complex galactic structures formed much earlier. This situation is difficult for conventional science to accept, as it still finds flaws with this model. Some areas of physics have outright dismissed this discovery, doubting the age estimates. Kaku is aware of this and had this to say: there are various outdated and misleading theories that persist due to the influence of certain experts. Many of these theories were only debunked when thorough research revealed their flaws. Thus, the key to any science, especially physics, lies with the experimentalists who keep researchers sharp and vigilant. On Earth, we have little understanding of the true origins of the universe. Kaku's statement underscores the importance of continuous experimentation and validation in the scientific process. The theory of cosmic formation was established in 1927 based on observations of the universe's expansion, leading to the conclusion that it began from a single point and has been expanding ever since. At the time, it was difficult for people and scientists to imagine a universe with both a beginning and an end. The idea of an eternal and boundless universe was beyond human imagination. Even today, scientists still grapple with this concept. However, it is essential to consider these possibilities even if these new discoveries do not align with what experts have anticipated for decades regarding the Big Bang theory. Science has repeatedly shown that reevaluation and openness to new ideas are essential components of the scientific process, much like the acceptance of certain theories and observations. When Einstein was young, it was once accepted that stars and planets were firmly fixed in the universe, occupying a defined space. However, we now know that everything in the universe is in motion. Planets orbit stars which move within their galaxies at speeds of several km/second, and entire galaxies rapidly traverse the universe whose fate we still cannot predict. This profound understanding of the universe challenges long-held beliefs and underscores the need for adaptability in science. Ceaseless requests and changes in logical ideas challenge researchers today to acknowledge awkward experiences and understand that speculations are not absolute truths until they are thoroughly tested or confirmed by precise observation. The idea of the Big Bang emerged from the recognition that galaxies are moving away from one another with their distances proportional to their separation from Earth. This observation, known as Hubble's law, suggested that the universe has been expanding over time. Elements such as cosmic background radiation and the red shift of light from distant galaxies, along with other cosmological patterns, seem to support this theory. However, it is essential to remember that in the past, people who believed the Earth was flat and that the sun revolved around us also had observational evidence for their beliefs until new events or technological advancements provided a clearer picture. Currently, we are seeing a similar situation. Scientists expected the new James Webb Space Telescope to confirm questions related to the Big Bang. Instead, they encountered 6 galaxies that appeared unimaginable. This shows that science is constantly evolving and researchers must remain open to new discoveries and reassess existing theories based on available evidence. The astounding discoveries have challenged current understanding and prompted a reassessment of long-standing cosmological speculations. Scientists use redshift as a tool to determine various metrics in the study of the universe. Red shift, also known as the Doppler effect, refers to the change in light's color as light sources and observers move relative to each other. To understand this, imagine standing still and hearing a vehicle approaching you. As the vehicle gets closer, the engine sound grows louder. However, when the vehicle passes by or moves away, the engine sound changes because the sound waves shift as the vehicle moves. The same principle applies to light. When a light source, such as a distant star, moves toward us, the light shifts to bluer tones. Conversely, when the light source moves away, the light shifts to redder tones. This phenomenon is called redshift. Physicists have converted redshift values into rates and distances for measurements in cosmological studies. However, it is crucial to note that even a small error in these measurements can have significant consequences. The estimation methods previously used are now under review. The latest discoveries related to our universe require consideration of whether they are genuinely based on redshift inaccuracies, or if some researchers are simply ignoring the facts. This is a question that calls for careful examination and a thorough review of the data and methods used in the research. The ongoing examination and reassessment of measurement techniques underscore the evolving nature of scientific inquiry and abundance of thanks for watching the video. As always, we remind you to post your questions in the comments section. If you enjoyed the video, make sure to hit the like button, share it so it reaches more people, and subscribe to the feed so you don't miss more content like this. Thanks for watching and see you in the next one. This call to action encourages viewers to engage with the content, fostering a community of curious minds eager to explore and understand the latest scientific discussions. The exploration of our universe with its vast distances and complex celestial bodies continues to captivate and challenge scientists worldwide. From early theories about the universe to the latest discoveries made possible by cutting-edge technology, each revelation reshapes our understanding of the cosmos and stretches the boundaries of human knowledge. One of the most significant and persistent questions in cosmology revolves around the origin and evolution of galaxies. Galaxies are like cities of stars, gas, dust, and dark matter bound together by gravity. They vary in size, shape, and composition, and each galaxy is a complex system where billions, even trillions of stars interact under gravitational forces. Understanding how galaxies form, evolve, and influence one another has become one of the central pursuits of cosmology, offering insights into the very structure of the universe itself. Theories about galaxy formation have evolved significantly over time. Initially, it was believed that galaxies formed in isolation, but research has shown that galaxies often interact, collide, and even merge, leading to spectacular formations and events. These interactions can trigger bursts of star formation and reshape galaxies, leading to new structures such as spiral arms or elliptical forms. Observations from telescopes like Hubble and now the James Webb Space Telescope have provided unprecedented images of distant galaxies, allowing scientists to peer back in time and witness galaxies as they were billions of years ago. In the early stages of the universe, the discovery of massive mature galaxies in the early universe as revealed by the James Webb Space Telescope challenges current models. According to the Big Bang Theory, galaxies should have started as small, simple structures and gradually grown larger and more complex over billions of years. However, these new observations show that some galaxies reached massive sizes very quickly, indicating that galaxy formation and evolution may be far more dynamic and complex than previously thought. This has led to intense debate and re-evaluation of how galaxies, including our Milky Way, came into being. The role of dark matter and dark energy also plays a crucial part in these mysteries. Dark matter, an invisible form of matter that does not emit or absorb light, seems to be essential in holding galaxies together. Without dark matter, galaxies would not have enough mass to counteract the force of rotation, and they would disperse. Yet despite its significant role, dark matter remains elusive. It cannot be directly observed, only inferred through gravitational effects. Similarly, dark energy, a mysterious force thought to be driving the accelerated expansion of the universe, continues to puzzle scientists. Understanding how dark matter and dark energy shape galaxies could be key to solving many unanswered questions in cosmology. Each discovery in cosmology opens new doors and challenges scientists to refine their theories, often requiring innovative approaches and advanced technology. As telescopes become more powerful and our ability to observe distant objects improves, we may find ourselves on the brink of a new paradigm shift in understanding the universe. Just as groundbreaking discoveries in the past reshaped our perspective, the current findings may eventually lead us to a deeper understanding of the cosmos, from the smallest particles to the grandest cosmic structures.